Here's a little homework help for Unit 4, Lesson 9. Question 1 talks about two cell phone plans, Plan A and Plan B. Plan A, you get $70 a month for your cost, but it comes with a free $500 phone. Plan B is $50 per month, $20 less, but it doesn't come with a free phone. So if you buy a $500 phone and choose Plan B, how many months is it until your cost is the same as Plan A? So we want to figure out, when is the cost of Plan A going to be equal to the cost of Plan B? If we talk about the cost, since we don't know the cost, let's say let X be the cost, or any number of months, since that's what we're saying, how many months we're after. We know that we have $70 per month for Plan A, we have $50 per month for Plan B, plus the $500 for the phone. And we want to know, at what point will the number of months be the exact same for when they cost the same amount? So when we talk about this, we want to go ahead and use our properties of equality, subtracting the months to show the difference, that it's a difference of $20 a month. And how long would it take to spend that extra $20 a month? How many months would it take to get $500? I hope that's enough information for you to finish the last part of that equation. Get that one answered. Problem number 2 is a comparison of Priya and Han. They're both biking in the same direction on the same path. This is a really good thing because that means that we can compare them directly to each other. Han is riding at a constant speed of 16 miles per hour. We're supposed to write an expression that shows how many miles Han has gone after T hours. That means that there can't be an equal sign here for us to be able to work with. Just leaving it as it is, we're saying he's riding at 16 miles per hour. Priya started riding a half hour before Han. That means she got a head start. That means for every amount of riding hours that either of them do, no matter what, Priya is always a half an hour before Han. We have to write that as a fraction because they said so. Priya is riding at a constant speed of 12 miles per hour. Complete the expression that shows how many miles Priya has gone after Han has been riding for T hours. Write the fraction in the form of A over B. Again, we have to remember that she has that half hour head start. And so as a half hour head start, we have to consider the part that Priya is riding at 12 miles per hour, but she had that half hour head start. That half hour head start put her 6 miles ahead of Han. So we have to consider this as saying that she's riding at 12 miles per hour. That's our time sign right here, per hour, plus the additional half an hour that she's been riding. So we kind of see that, understand this piece, that through distribution, 12 times T is right here, 12 miles per hour. 12 times 1/2 is 6 miles in that half an hour. So this would be Priya's expression. We need to look at both expressions now, 16T and 12T plus 6. All these expressions to be able to find out when Han and Priya meet. Write a fraction in the form of A over B. I want you to take some time to think about this one, give it a roll based on what I have. I'm going to give you a lot of help on these, but I'm not going to give you everything. So take that last one. Question 3 is a comparison. Which story matches the equations? -6 is equal to 3 times X is equal to 2 times X plus 4. First one, temperatures recorded at 2 weather stations in Antarctica are -6 degrees. I'm going to call that station A, and then 2 degrees, station B. The temperature changes at the same constant rate. That's really cool, which means that we have X degrees per hour throughout the night at both locations. The temperature at the first station 3 hours after recording is the same as the temperature at the second location. So when we're talking about first location, that's first location, that's first location. I see that -6 and the 3 times the number of hours matches up perfectly here. Same thing with the second one, 4 hours at the second location. I'm inclined to believe that this is A, but let's figure out why B would be incorrect. Elena and Kieran play a card game. Every time they collect a pair of matching cards, they earn X points. Cool. So each pair is X points. At one point in the game, Kieran has -6 points. Elena has 2 points. Okay, makes sense. That tells us that this side over here is Kieran, this side is Elena. So we have -6 for Kieran, and Elena has 2 points. After Elena collects 3 pairs, so, this is a K. So Elena collected 3 pairs. So she had her 2 points plus 3 pairs. And then Kieran had 4 pairs. They have the same number of points. And when I compare those two equations to each other, they don't match up here. This one would suggest that Kieran added 3 pairs and Elena added 4 pairs, but that wasn't really the case. I know for a fact that A is definitely correct. Number 4 is just one to what value does X make these expressions equal to each other, have the same value. What we need to do with this one is we need to go ahead and solve for X. So 2/3 of X plus 2, we're saying at what point will X have the same value, meaning when will these expressions be equal to each other? Don't forget that when you see fractions like this, before you start to panic, take a deep breath and say, what strategies do I have that can help me to solve this? One of the major strategies that we've been talking about is multiplying by the common denominator of all of the fractions. In this case, both of these denominators have a 3. So if I multiply both expressions by that common denominator, what happens is that common denominator becomes eliminated or becomes an integer instead of a fraction. So when we talk about 3 times 2/3, 2/3 of 3 is 2. So that makes that one under distributive property 2 times X. And then 3 times 2 would be 6. Over here, 4 times 4/3, 4/3 of 3 is 4. So 4 times X. And then 3 times that minus 6 is a minus 18. Hopefully that gets you started enough to be able to solve the equation. Don't forget to check your solution when you get to the end. When you enter your solution, just enter the answer because they already gave us, or enter the value of your variable because they already started at X equals. And if you put X equals in there, it's going to mark it wrong. The next 3 questions are all really, I guess it's not this one, it's 6, 7, 8, 9, or 6, 7, and 8. In this one, we need to compare for all solutions. Remember, infinitely many solutions, any value can make it true. One solution or no values at all for X. Our comparison, when we look at these, one solution, we have to remember one solution has different coefficients. And if you really think about it, when we talked about no solution and infinite solutions, they had the same coefficients of X. They had that value is the same, and so it can be eliminated. And then when we compare the constant values, we find out for sure if it's true or false. But the one thing about one solution is different coefficients, because under different coefficients, the variable term is not eliminated. It can't be eliminated. In this case, when we look at question letter A, we see 2 times X and a minus 3 and 5/10 X. That's a dead giveaway right there that that's one solution, simply because the coefficients of X are different, which means if I added 3 and 5/10 X to the left side, I'd get 5 and 5/10 of X, which means X is not gone. It means I can still solve for it. I would have to consider the same thing with part B. We have 9 times X after distribution compared to 7 times X after distribution. Different coefficients, one solution. Letter C, as I simplify, 3 times 3 is 9 times X plus 6 minus 2 times X. And I simplify further, like terms are 9 times X and a minus 2X. So 9 times X minus 2X plus 6 is the same thing as 7 times X plus 6, which is compared to 7 times X plus 6. Now, as we think about, like I was talking about those coefficients earlier, if I combine those terms, those like terms, using subtraction property of equality, we eliminate the variable completely, and we're left with the expression 6 is equal to 6, or the equation 6 is equal to 6. Now the question is, does this make this all solutions are true or no solutions are true? Take a minute to review. Remember, make your selection, and join me on the next problem. This is the first problem of 3 that are going to go through the same thing. We are at kind of a disadvantage here because we're trying to predict what they want us to do. But as long as we have a firm grasp on the properties of equality, we're going to do a good job. I want to offer some suggestions for how to figure out which steps are correct. The very first thing we want to do is they're offering us this: select your choice based on the right side of the equation. You can either distribute or you can factor. Remember, distribution is multiplying, distributing is dividing. So we have that option of where we can either multiply -2 times both, or we can divide by -2 on both sides. Here's my suggestion. If you look at the division, 3d divided by -2 would give us -3 times d halves, or -3 halves times d. Everything that we've looked at has suggested that we stay away from the fractions, or that we fix the fractions by using distributive property, multiplying by the common denominator. Here's the thing that would also help me to realize that dividing or using factoring is not the right choice, is because the next selection says, what do you want to do with the 10? I don't see any 10 in there. And so what I have to think about is this. Under the distribution, we would have -10 plus 6 times d, which indicates that there's something that needs to be done with the 10d, or with that 10 that's going to be there on this side. And then we have to go back to the other question about 3d, and then whatever it may be. So what I'm getting at is this. We've gotten started where we already say, well, this next one has a 10, so it must be that I have, that this is the route I have to go. The next says, what are you going to do with that 10? Well, I'm going to add the 10 to both sides, and I get 3 times d plus 26 is equal to 6 times d. And then the next question says, what do you want to do with 3d? And then what do you want to do with the 3? I hope that that's enough information to get you started and a little bit of help. I'm going to offer the same kind of help on the next couple of them as well. Number 7, same thing, a little different situation, but now they're saying, do I distribute or do I factor and combine like terms on the left side? Well, with this one, I'm not going to factor on the left side, simply because if I factor this, I'm going to be saying divide by 2k and divide by 3. It's really not something that's going to help me out, especially when my next question says, what am I going to do with 3k from each side? The reason that I know that is because if I distribute here, I get 2 times k minus 12 plus 3k. After I have those, then I combine them. I end up with 5 times k minus 12 is equal to 3 times k plus 4. And so it makes sense at this point to understand that they're wanting us to pay attention to 3k. Do I add it or subtract it? Because that's the only way to get that 3k, or to just have a 3k, is through distribution here and then combining the like terms. I think that's enough information to get you started with the rest of it, or to get you going on the rest of it. The last of these 3 questions, ask this one. I think this one could be the most complicated, but again, notice the strategies that I used, that I was actually showing my work and checking those values before I actually made a decision. In this case, I can either multiply or divide each side by 9. Let's look at the consequence of, we'll just start with multiply, because I see right here that it's division. So multiply seems like the logical choice to me. If I multiply this expression times 9, and if I multiply the other expression times 9, let's look at what's left. Remember that we're multiplying by 9 on the denominator to eliminate the denominator. That leaves me with 3 times y minus 6. When we look at this side, we can eliminate this denominator because 9 divided by 9 is 1. What we might want to look at right here is rewriting this, or reimagining this, as 9 times 4 minus 2 times y divided by, and put the -3 under the 9. That's the only part of the expression on the right side that will be affected by multiplying by the 9, is that denominator. And so what we see with that is 9 divided by -3 is -3 multiplied by the grouping that was on the top. Now the question that comes in next has us say, select a choice for -3 on the right side. Well, what would I do with the -3 on the right side? The options that they give us are distribute or factor. I know that I'm on the right track doing what I did over here by multiplying by 9, because now I have a -3 to work with. That -3 is right here. So what would I do with that? Would I distribute that or would I factor that? Think about the next step. I want to get 3y. I have a couple of options here. If I choose to distribute this right over here, I would get -12 plus 6 times y. If I choose to factor the -3, then I have to consider what my consequence would be. Factoring the -3 would be divided by -3 here and here, which means that I would get -1 times y minus 6 is equal to 4 minus 2y. While there's nothing wrong with this situation, I no longer have a 3y to work with. That tells me that I'm not going to factor. Factoring is the wrong choice, because then I don't have an option for my next situation here of working with that 3y. And so my only option here is to distribute that -3 on the right side so that I have 3 times y minus 6 is equal to -12 plus 6 times y. That leaves me with the opportunity to work with the 3y of either adding or subtracting this 3y right here. Had I factored, I don't have this anymore. So what I'm telling you with this, just again to reiterate, do the steps first. Not to say that what I did with factoring was wrong. There's nothing wrong with that. It's just not the direction they wanted us to go this time. The whole goal of these equations, these last 3 problems, is to help you recognize there are so many different ways to solve the equations. Keep your mind open, because a lot of the times those situations, as we get better at them, we're going to see how to answer these questions in more efficient and more effective ways. The final problem here is just a review problem going back to lesson 1.7, talking about rotation. I will tell you just off the top, don't even consider A, because 60 degrees is really not reasonable. I want you to think this is in a completely different quadrant. It has a different appearance. 60 degrees would not get into another quadrant. Only 98, 180, and 270 would. This one is all up to you beyond this point. Thanks for tuning in. Thanks for your hard work. I'm out. Have a great day.